Hello and welcome to Buildings of Tomorrow. My name is John Lester, and today we are talking about wireless technology in buildings. I'm really excited to be joined today by Michele Remonato. He is the head of IoT Devices at Siemens in Building Technologies. Michele, thanks for joining us.
Hey, John. Great to be here with you.
I'm excited because when we talk about wireless technology, and as an industry, we talk a lot about smart buildings. We talk about how buildings need to be more connected. We need to gain data. We need to understand data. We need to leverage modern technologies. It's the time that wireless really has the opportunity to have a huge impact. But my first question is about wireless itself. Wireless is not new. So where are we today, and what's different today than in the past from a wireless technology perspective?
Yeah, you're absolutely right. Wireless has been around for a while. And I think to understand where we are going, we need to understand from where we come from. I think wireless solutions have been available in different forms for a very long time. We talk about decades. And in the past, access to wireless technologies was limited due to the cost of the chipsets, the overall maturity of different industries. And also the general availability of user-friendly workflows. Gradually, this is changing, and in fact, in the past, many companies used to have own wireless proprietary solutions and used to have own workflows. Now we see a wave of standardization. We see a general trend of chipsets becoming cheaper and cheaper. So this is basically enabling a wider and more pervasive adoption of uh, wireless solutions. And that's where we are heading. We're heading towards standardization. We're heading towards much wider availability of solutions towards different use cases. So it's an exciting future in front of us.
Perfect. And what I like about that is that this is kind of a trend that we see in many other technologies in the past, right? That we see the costs come down, we see adoption and maturity go up, and that drives standardization. And once we really hit that standardization, that's when we can unlock the power, whether it's wireless technology or some of the technologies before. Now, at the start, in this first question, we talked about smart buildings, we talked about connectivity, we talked about buildings having to be able to deliver better functionality and be more connected to buildings. Is wireless a technology, a key enabler to actually help us achieve that at a scalable level?
Absolutely. I think we see ever increasing amount of use cases that around smart buildings. Just to give you a few examples, we can use wireless to do connected automation, right, for our HVAC applications. We can use it for lighting. We can use it for metering. Personally, I find wireless very interesting technology also for monitoring. For example, indoor air quality, which is such an important use case in our post-COVID era. So there are a ton of use cases. I could go on for hours, but there are very many use cases that are now possible with wireless, and that also increase the value of the buildings themselves.
Yeah, I understand. And you mentioned some great use cases there. Indoor air quality is definitely one that is also really at the top of our priority list as an industry, as we understand more and more the impact that indoor air quality has on us. And wireless brings with it so many inherent benefits: more flexibility, easier installation, faster deployment, etc., etc. But wireless is not just wireless, right? There are different types of wireless networks that have their own capabilities. It's not just all the same. So give us a little bit of a snapshot. What are the different types of wireless networks, and where are they strong? Where the benefits lie, and where are some of their weaknesses, and what are those use cases that come with that?
Sure. I think, let's say, the wireless technology world is very complex. There are lots of possibilities, and there are a lot of different ways to look at the configurations. But I would say for anyone that wants to understand it on a high level, there are three main types of configurations or networks, right? The first type are mesh networks, where basically you have devices that are close to each other, and each device can talk to all the other devices, and they become like a net. And it's a very reliable um, network where you can do monitoring, and also you can command things or automate things. we use that in connected automation for HVAC, for comfort. We use it for lighting, and users have a very high expectations on this kind of networks.
Yeah, right. And so that mesh network, very reliable. Everything's talking to itself. But what does that? What limitations does that come? What are some of the things like? Are they good for close proximity? Are they good for regular? You talked about automation. This means like regular communication. What are some of those characteristics?
Yeah, so normally these networks are smaller. So in wireless, you always want to think about how far you need to send your data, your signal, right? So these kind of networks are very good when you are, let's say, maximum 100-meter distance, right, between devices. And one example is Zigbee in residential or smart home application. This is quite popular. There is a upcoming, let's say, technology which is called Thread. Also, maybe some of the people that are listening in may be familiar with Matter. Is another technology that is upcoming. So you can send also several megabits of data, but of course this comes at a cost, right? The limitation is that you consume a little bit more power compared to other solutions, and the distance between the devices is lower. But this all comes to the benefit that you have a much better user experience. So if you trigger something from your phone, if you turn off a light, the reaction time is milliseconds. So for you as a user, you have a very nice user experience, right? Imagine if you would wait 1 second before your light turns off. You would not feel right, right? So the limitations on distance and battery consumption are paid off by a better user experience and a much more reliable network, right? So if you need to automate your home, if you need to automate even a commercial building, that's much more reliable.
Understand. So more information can be sent. It's more reliable. It can have a fast reaction time. But of course, these things don't come for free. So there is that limitation on distance. There is that limitation from a battery perspective. So that's a mesh network, if I remember rightly. You mentioned three. So what's the next one in our different types of wireless networks?
Yeah, there is a second type, which is called wide area low power. So before we were talking about hundreds of meters maximum. Now we talk about a few kilometers. And these solutions, they have two key characteristics. So the wide area, so to cover a wider surface, right? Imagine a campus, right? Like a university campus or a very large mall. And the other characteristic is to consume very little power. Yeah, so that you have a battery powered device that you can live in the field for years. And in this field, let's say typical use cases are around monitoring or measuring consumption of energy or tracking some assets. And so it's much more used for monitoring rather than to actually automating things. But you could still do it. But the monitoring is the key use case. And technologies also in this field that are interesting, like MB-IoT is very popular in Asia. LoRaWAN is another technology. There are many technologies also in this space, and they're becoming more and more affordable over time.
Okay, perfect. So we have the mesh network, which is great for automation, for operation, fast reaction times, and a lot of information can be sent. We've got the wide area, low power networks, which are, like you mentioned, best for once an hour, once a day, sending an update to an energy trend or something like this, but not for regular ongoing updates. And then have the benefits: longer distance, longer battery lifetime, lower power consumption. Number three. What is number three for us?
Yeah, the number three is the one that you use every day. We use every day with our phone, our cellular networks, right? So 5G networks are now really popular, but 4G, 3G, basically you can send data through the internet, right? Through the different internet service provider from any device. So this is like extremely popular and pervasive in consumer business with phones and mobile phones, tablets, and so on.
Mm-hmm.
But it can also be used in industry. It can also be used for commercial buildings, for data centers, for hospitals, and so on. And basically, the key advantage is that first of all, we can transmit towards a centralized cloud or towards a place that is far, far away, quite a lot of data. And I mean like tens of megabytes per second, right? Um, the advantage is that basically we can send it anywhere. We can do it for devices that are really further away from each other. But of course, this comes at a cost. Normally, these devices need to be recharged or need to anyway have some sort of cabling to get the power supply. And of course, then there is more network infrastructure to put in place, and this comes at a cost that the internet service providers normally charge as a monthly fee or as a per data fee. Um, but these are also possible to use in industry, in buildings, but you will also find it in factories, right?
Mm-hmm.
And of course, these networks can be configured in different ways. They can be public, they can be private, but in a high level, also this is possible.
Yeah, right. So when we talk about wireless, there are many different technologies. We have these mesh networks, we have these wide area, low power networks, we have the cellular networks that we know so well. All of them have different strengths and weaknesses, and that's part of the power now, right? We have different solutions to suit different use cases, and we can pick and choose depending on the requirements and the expectations. My next question is about challenges because, like we talked about before, wireless has been around for a while. We have new technology, we have a more mature industry to manage this kind of technology, but as always, when we have more connectivity, when we have wireless technology, there are some challenges that we have to overcome, or be at least aware of. What are some of those challenges that you see that we need to be aware of, that we need to overcome when it comes to wireless technology?
This is a very good question. That's where we from industry and from we can bring in the domain know-how. So, from with the previous question, we were sort of abstracting the different technologies, right?
Yeah.
Uh, our job, also my job, is to then match it with the different use cases. So, first of all, different network types fit well with different willingness to pay, different budgets.
Mm-hmm.
So if a customer is only asking to do monitoring and it's okay with a supervision and they don't need to automate things and they maybe need to do billing or reporting, then, for example, a wide area low power network is much better. If a customer wants to do heavy automation, then definitely I would recommend a mesh network. But they have different price points, right? Because one has lower cost in terms of network equipment, effort to configure. So definitely the total cost of ownership is one key challenge, right? To find the right solution in terms of price point for the different expectations, the different project that we need to solve. The other variable is how far and do you want to send the data, right? So, and across which kind of ceilings or barriers does this data need to go? Every building is different. Every uh, construct is different in terms of materials. So also there, the recommendation has to be geared towards the specific building type. Is it an airport? Is it a small school? Is it a residential building? So the type of building is also a very important criteria. And I think a third criteria is also what is the expectations around the energy consumption. So not always we will have the possibility to use a power plug, and so we will need to use battery, and then we have to match the right solution um, depending on how reliable the battery duration can be. So I think to summarize it, we need to look at the price point, we need to look at the type of building, and we need to look how we can supply the energy to the devices. So this is where the domain expertise come in, and this is where I'm personally really excited because we never had such a wide range of options, to solve problems for our customers. So,
And that's a huge difference, as you say. Because you have these limitations, whether they're physical limitations with the distances or the type of building, and we have those personal experiences in the past when you have a concrete building versus a prefab building, etc. Different situations, different characteristics. But in the past, you kind of had option one, and it either worked or it didn't. And if it didn't, then back to the drawing board. And I think that's what you mentioned. You're so excited now because if option one doesn't work, you have option two and option three. And now that we have those skills and capabilities, we can start to say, well, what is that specific requirement? What are the things that we have to overcome, and how can we make that work for us in this particular situation, fit that use case, but also fit the physical constraints? Um, One challenge that I was interested in is, and it's always a hot topic for our industry, but all industries, is cybersecurity. When we're talking about wireless, are there any additional considerations or challenges that come with this technology that we have to keep in mind when we think about cybersecurity?
Absolutely. So the signal is transported over the air, right? And there are always risks associated to potential theft of the data. So, without going too much deep in the technology, basically, this is why it's good to rely on standards which are industry proven and where there are the eyes of multiple vendors, but also of multiple consumers and also of multiple hackers, because this ensure that when, let's say, cybersecurity issues or even, let's say, faults are found, then they are quickly resolved. So in general, let's say there is always a risk associated to using any sort of technology. The good thing is to rely on encrypted wireless technologies and on standards, because standards are normally much more under the lens, right? So what we do also from our point of view, from a company point of view, we rely on proven technologies, right? Which are also part of standards and where there is a very high level of transparency also towards the end users and towards our customers.
Yeah, perfect. And that is such a big part of it, isn't it? As you say, it doesn't really matter what technology you're using. In the end, we're transmitting data. So whether we're transmitting that via a cable or we're transmitting it via the air, it's always accessible. So those industry standards, those encryption and that understanding as an industry are essential to make this something that can happen and continue to be up to the expectations moving forward. Last question. You mentioned earlier many different use cases, and you mentioned indoor air quality as well. You know, let's talk a little bit more, just in a bit more detail about that opportunity. Like, why are you so excited about indoor air quality as an example? Why is wireless technology uh, present such a cool opportunity around this specific topic?
Yeah, absolutely. And as always, I like to tell a sort of a story. Imagine when you talk about indoor air quality today, I would say the largest percentage, so 80+% of buildings have wire sensors, and you need one sensor for temperature, one sensor for humidity, another sensor for I don't know PM 2.5, which is a fine dust measurement. But there are many more measurements, right? And now with the post-COVID era, you may also want to retrofit buildings where doing the cabling again, it's quite complicated, and there are many new metrics that we want to measure. Right, we have the PM 10, for example. We have also organic compound in the air. There are many metrics. So I don't want to get into it now, but now imagine. First of all, the technology enables to have a multi-sensor,
Mm-hmm.
so to measure multiple measurements in the same device, to have it wireless, so to basically place it in any sort of building, right? And also to do it for any size of building, right? So you can do it for a small building, either you can do it in a mesh network, but in this case you just want to monitor, so you will do it in a wide area network, and then to get all the data into a controller, but also into the cloud, right? So basically, we solve a problem, which is a problem of our era, that we want to keep track of air quality, and we can basically do it with a plug and play solution. It doesn't get better than this.
Yeah, it's true, and it's such a poignant topic for us at the moment as a society, not just an industry. And as you say, that ability to be fast, that ability to be flexible, that ability to combine technologies and have that native connection into already existing control systems and to the cloud. This is the value proposition from wireless, right? This is why we're excited, which is really cool. Michele, thank you so much. Great conversation. I kind of get the feeling we just scraped the surface, so I'm excited to talk a little bit more in detail about some of these different wireless technologies and some of the use cases. But hey, thank you so much for the time and your information. It was really enjoyable, and it was great to have you here with us today.
Thank you, John. It was a pleasure, and I look forward to the next one.
Bring it on. So thank you to you, Michele, and also thank you to anyone that's out there listening today. Remember to like, share, comment on this episode, subscribe to our show wherever you're listening to it, whichever platform or you enjoy, or also watching in this case. And keep your eyes open because we have new episodes coming often. And find myself or find Michele on LinkedIn and reach out to us. Let us know what you want to know more about around wireless technology or any other technologies in the building industry that you're interested to look at. So, hey, until then, enjoy, be safe, and we'll see you very soon.